Welcome to the Art of Mathematics. So today I'm gonna do my last video on rational equations. Please subscribe. I'm gonna have some videos on long division with variables like x and y, and I'm also gonna have a series on functions. So here I'm just gonna solve one equation, and I have two examples from the way how I solve rational equations. It's a quick and dirty way to do them. Okay, so let's begin. I'm going to solve this equation here. Now, if you look at the bottom, the three terms are x plus 5, x plus 3, and x plus 1. So the first term here, x divided by x plus 5. So that already has an x plus 5. So what I say, it already has an x plus 5, so it's 8 times x plus 3 times x plus 1. And that's what I have down here. Plus, then this term here already has an x plus 3. So I say plus 6 times x plus 5 times x plus 1. And that's what I have at the bottom here. Plus 6 times x plus 5 times x plus 1 is equal to 2. Now this term here already has an x plus 1. So it needs an x plus 5 and an x plus 3. So it's equal to 2 times x plus 5 times x plus 3. And there I have this equation. Because remember, you're going to have to multiply each term by this term here. And then the 5 is going to cancel out in the first term. So you're left with x plus 3 and x plus 1. Then if you multiply the second term by this long term, the x plus 3 is going to cancel out, and you're left with x plus 5 and x plus 1. And then the last term here, if you multiply it by this long term, the x plus 1 and the x plus 1 are going to cancel out, and you're left with x plus 5 and x plus 3. So I'll leave it, the video that I explained this in the cards above. So then we're left with this equation here. Don't worry if you don't fully understand it. I'm going to do two examples extra that I'm not going to solve. I'm just going to show you the method that I use. So then this is just multiplying out. So it's x squared plus 3x plus 1x. So it's plus 4x. And then 3 times 1 is plus 3. Then it's x times x is x squared plus 5x plus 1x is 6x plus 5 times 1, which is just 5. Then it's x times x is x squared plus 5x plus 3x is plus 8x. And then plus 5 plus 3 is just plus 13, plus 15, sorry. So if I multiply that out and take everything to the one side, then I'm left with 12x squared plus 52x plus 24 is equal to 0. Then I can divide by 4, and I'm left with 3x squared plus 13x plus 6 is equal to 0. Now I can't really see easy terms that I can factorize this equation, so I'm going to work out the determinant. It's 13 squared minus 4 times 3 times 6, which is 97. And our final answer is x is equal to minus 13 plus or minus the square root of 97 divided by 2 times 3. So this is using the formula to solve quadratic equations. So our final answer is x is equal to minus 13 plus the square root of 97 divided by 6, or x is equal to minus 13 minus the square root of 97 divided by 6. So just some examples. So you can see here we have to solve this equation. So we look at the first term here, or we look at the bottom first, sorry. So the bottom, all the terms are x times x plus 3 times x plus 4. That's all the terms. So now we look at the first term here, the x plus 1. So the x plus 1 already has an x plus 3. So it only needs an x and an x plus 4. So we say it's x plus 1 times x plus 4. And that's what we have here. Plus, so we go to the next term. Now this x plus 2 already has an x plus 4. So it only needs an x and an x plus 3. So we say plus x plus 2 times x plus 3. And that's what we have here in this part here. So then we have the equal sign. So then we say 5, it already has an x, so it only needs an x plus 3 and an x plus 4. So we say it's equal to 5 times x plus 3 times x plus 4. And then we just have to multiply these out, and then we have to solve for x. So this is my last example. So you can see here the bottom terms. Sorry, I lost my mouse. The bottom terms are x plus 3, x plus 2, x plus 1, and x plus 12. So if you look at the first equation, or the first term, sorry. So the x plus 8 already has an x plus 3. So it only needs an x plus 2, an x plus 1, and an x plus 12. So then it's 8 plus x times x plus 3, x plus 2, sorry, x plus 1, and x plus 12. Then we say plus, then we go to the next term. So the next term already has an x plus 2. So it only needs an x plus 3, an x plus 1, and an x plus 12. So we say x plus 4 times x plus 3 times x plus 1 times x plus 12. Then we go to the next term, and we say plus. Then this x squared, the x plus 6 already has an x plus 1. So it only needs an x plus 3, an x plus 2, and an x plus 12. So we say it's plus x plus 6 times x plus 3 times x plus 2 times x plus 12 is equal to, then the last term, the x plus 5 already has an x plus 12. So it only needs an x plus 3, an x plus 2, and an x plus 1. So you say it's equal to x plus 5 times x plus 3 times x plus 2 and times x plus 1. And then we have this equation here. So if you do it with the correct method, you would just multiply each term with x plus 3, x plus 2, x plus 1, and x plus 12. So then in the first term, the x plus 3's will cancel out. Then in the second term, the x plus 2's will cancel out. In the third term, the x plus 1's will cancel out. And in the last term, the x plus 12's will cancel out. So that's why there aren't an x plus 3 here, there isn't an x plus 2 here, there isn't an x plus 1 here, and there isn't an x plus 12 here, because they were cancelled out. So you just actually take, for the term, you take everything else at the bottom except the one that's at the bottom for that term. So this is just a quick and dirty way to skip the first step and just go straight to this equations with no fractions and then just multiply them out. I used this method right through high school, and thank you guys for watching. I hope you enjoyed this video, and please have a lovely day. Please remember to subscribe, and remember that you're a lot smarter than your calculator.